Hello children, welcome back to my channel. I am dealing with 9th class maths in the chapter areas. Exercise 11.2 I have to do. In this exercise 11.2 the first sum is area of a parallelogram ABCD. This parallelogram ABCD area is given as 36 square centimeters. Area of parallelogram ABCD is equal to 36 square centimeters. Then calculate the height of parallelogram ABEF. See children, they have given parallelogram ABCD area, but they are asking the height of ABEF, in which AB is given as 4.2 centimeters. So how it has to be done? Now children, ABCD parallelogram and ABEF parallelogram are lying on the same base and in between the same parallels. Therefore, they will be having equal area. So, we say that parallelogram ABCD and parallelogram ABEF lie on the same base and between the same parallels. Therefore, we will be saying that area of parallelogram ABCD is equal to area of parallelogram ABEF. Both of them are having same areas. Why? Because they are lying on the same base and between the same parallels. Therefore, area of parallelogram ABEF is equal to 36 square centimeters. And what is the formula for area of parallelogram? It is nothing but base into h. Therefore, base into h is equal to 36. What is base? Base is nothing but AB. This is 4.2 centimeters. It is nothing but the base. So, base is AB, that is 4.2 into h is equal to 36. So, what is h children? H is equal to 36 by 4.2. So, take a 0, you can cancel. 2 2s are, 2 1s are, 2 1s are, 2 8s are 0, 3 7s are, then 3 6 are 0. So you are getting 60 by 7 means 7 8s are 56, 4 you will be getting 7 5s are 35, 5 7 4s are 7 7s are 49. 8.57. Therefore, height of parallelogram ABEF is equal to 8.57 centimeters. This is the answer children. Please note it down. I hope I am clear. Once again, let me explain. They have given area of parallelogram ABCD. This is the figure given to you, children. In this ABCD is one parallelogram, ABEF is another parallelogram. These two parallelograms are lying on the same base and in between the same parallels. So when parallelograms lie on the same base and between the same parallels, they are having equal in area. So basing on this property, area of ABCD is equal to area of ABEF. What have they given? They have given area of parallelogram ABCD as 36 square centimeters. If ABCD parallelogram area is 36 square centimeters, definitely ABEF parallelogram area also is 36 square centimeters. And formula of area of parallelogram is base into height. So base into height is 36 centimeters. What is base, children? This is AB. This is base. So base is equal to 4.2 into height is equal to 36. So on calculation, I have got H value as 8.57 centimeters, children. Please note it down. This is first problem. Now, children, second problem. ABCD is a parallelogram in which AE is perpendicular to DC and CF is perpendicular to AD. And AB is given as 10 centimeters, AE is given as 8 centimeters, and CF is given as 12 centimeters. Now the question is, what is AD? See, children, this is only one parallelogram they have given. So, area of a parallelogram ABCD is equal to base DC into height. DC into height is AE. But what is DC? DC is equal to AB. That is equal to 10 centimeters. Why is it? Because ABCD is a parallelogram. Opposite sides of parallelograms are equal. So DC is equal to AB. And what is AE, children? AE they have given us 8 centimeters. Therefore, area of parallelogram ABCD is equal to 10 into 8. Also, area of parallelogram ABCD is equal to AD into CF. Why is it? Because both of them are same parallelograms. So, if you take DC as base, DC into AE you will write. If you take AD as base, AD into CF you will be writing. So, area of parallelogram we have got 10 into 8 is equal to AD we don't know, but CF we know. CF is 12. Therefore, what is AD, children? AD is equal to 10 into 8 by 12. 4 2s are 4 3s are. Anything you cannot do, so it is 20 by 3, that is 3 6 are 18, 20 again, 3 6 are 6.66, 66 so on you will be getting, that is you can consider it as 6.7 approximately. Therefore, AD is equal to 6.7 centimeters approximately. This will be the answer correction. See, ABCD is a parallelogram, they said. AB measure they have given. And AE is perpendicular to CD. AE is 8 centimeters. And CF is perpendicular to AD. CF is 12 centimeters. Now the question is, what is AD? We know that the area of parallelogram is base into height. So in this case, since it is the perpendicular drawn, this becomes base CD into AE. CD is what? See, CD is equal to AB because opposite sides are equal in parallelogram. So CD or DC is equal to AB, that is 10 centimeters, because ABCD is a parallelogram and AE is 8 centimeters. So area of parallelogram is base into height, that is a 10 into 8. And also area of parallelogram ABCD, if you take this as base, it is AD into CF. So AD we don't know, but CF is a 12. So 10 into 8 is equal to AD into 12. So AD is equal to 10 into 8 by 12. On calculation, I have got it approximately 6.7 centimeters. Children, please note it down. Now, third problem, children. This is the figure given to you. If E, F, G, H are midpoints of AB, BC, CD, and AD, then you have to prove that the ABCD is a parallelogram. You have to show that area of EFGH is equal to half area of ABCD. Half area of ABCD. This you need to prove, children. Area of EFGH is equal to half area of ABCD. This we need to prove. So we know that ABCD is a parallelogram and E is the midpoint of AB. F is the midpoint of BC. G is the midpoint of CD. And H is the midpoint of AD. Now what is that? This is what we can write it as given. What is RTP? What we require to prove? Area of EFGH. Area of EFGH is equal to half area of ABCD. This is what we need to prove. So here we have got a construction, children. Construction given here is you have to join HF. This HF you have to join. You have to draw broken lines as it is a construction. Because of this, see, ABCD is divided into two parts. So now we can say that ABFH is also a parallelogram because these two are the parallel. This is a parallelogram, and this the H and F are the midpoints of the opposite sides. So definitely the line drawn will be a parallelogram. So we can say that proof we are going to do. See, A, B, F, H is a parallelogram. Why are you saying this as a parallelogram? Because F is the midpoint of BC and H is the midpoint of AD. Why is it? Because F or we can write the line joining the midpoints of, it is nothing but the line joining the midpoints of opposite sides of parallelogram are parallel. See, the line joining the midpoints of opposite sides of parallelogram is not R, is parallel to AB. Because the line joining midpoints of opposite sides of parallelogram is parallel to AB. You can even write parallelogram ABCD. Parallel to AB. So this is parallel to FH is parallel to AB because these two are midpoints and this is the line joining the midpoints of the opposite sides of parallelogram ABCD. They are parallel to AB actually. So ABFH is a parallelogram. And so because of this, what is happening? You are getting a triangle. Therefore, triangle EFH and parallelogram ABFH lie on the same base and between the same parallels. See children, EHF or what I said, EFH. EFH is a triangle. ABFH is a parallelogram. These two are lying on the same base, EFH, and lying on the base between the same parallels, AB and FH. So they are triangle the EFH and the triangle ABFH is because they are lying on the parallelogram, they are lying on the same base and in between the same parallels. We will be saying that therefore area of triangle EFH is equal to half area of parallelogram ABFH. What is that children? Triangle EFH and parallelogram ABFH lie on the same base and between the same parallels. Therefore, what you can say, EFH area, triangle area is nothing but half of parallelogram ABFH. Similarly, this is the symbol for similarly. Similarly, area of triangle FHG or GFH. We can say triangle GFH is equal to half area of parallelogram CFHD. Okay, parallelogram CFHD. So, what is that they are asking you? They are asking you to find out area of EFGH. Area of EFGH, see, EFGH is nothing but area of triangle EFH plus area of triangle GFH. If you add these two areas, you will be getting area of EFGH. But what is area of triangle EFH? It is nothing but half area of parallelogram ABFH plus half area of parallelogram CFHD. So what is this children? This is nothing but half of area of parallelogram ABFH plus area of parallelogram CFHD. What does this children? I'll write it here. What do you mean by this? See, area of ABFH plus area of CFHD. Anyway, these are all nothing but this total is nothing but parallelogram ABCD, that is equal to area of parallelogram ABCD. Half area of parallelogram, half is be here children, half area of parallelogram ABCD. So let me take some place here so that from here I'll write So that is equal to half area of parallelogram ABCD. Therefore, area of EFGH is equal to half area of parallelogram ABCD. Hence, proved. So, this is the proof, children. So, this part I am dividing like this. So, this is the proof of this problem, children. Once again, I'll explain. ABCD is a parallelogram given. E, F, G, H are the midpoints of AB, BC, CD, and AD. You need to prove that area of EFGH is equal to half area of ABCD. So for this there is a construction, you have to join FH. Because you have joined FH, you are getting ABFH as a parallelogram because the midpoints, the line joining the midpoints of two sides of opposite sides of a parallelogram will make AB as a AB parallel to FH. So when it is a parallelogram, ABFH and triangle EFH are lying on the same base HF and in between the same parallels. So area of EFH triangle is equal to half area of parallelogram ABFH. It is a theorem which you have learned, children. So similarly, we can prove that area of triangle FGH is equal to half area of parallelogram CEFHD. So you want EFGH area. That means this triangle plus this triangle area. So area of EFH plus area of GFH is nothing but half area of ABFH plus half area of CD or CFHD. That is nothing but area of ABCD. Therefore, we can say that area of EFGH is equal to half area of parallelogram ABCD. Please note it down, children. So the fourth question is, what type of quadrilateral do you get if you join APM, DPO, OCN and MNB in example 3 they said. So what is example 3? Example 3 says that midpoints of adjacent sides of rhombus ABCD are MNOP. The problem is different but important points I have taken here. ABCD is a rhombus, children, and M is the midpoint of AB, N is the midpoint of BC, O is the midpoint of CD, P is the midpoint of AD. The figure that you have got in example 3 is different, but here what are they asking? They are asking to join PM so that you will get triangle APM, and join OP so that we will get DPO, and triangle OCN we will get here, triangle MNB we will get here. So the question is, what type of quadrilateral do you get? See, you are getting a quadrilateral here. So what type of quadrilateral is it? That is the question. This should be joined in this way. What type of quadrilateral are you getting? That is the question here. So what type of a quadrilateral means? We need to talk about name of the quadrilateral. So for that, what you do? Let us join B and D. Our construction is join BD. If you join BD, since MP point M is the proof. Proof is M is the midpoint of AB, this is given to us, and P is the midpoint of, what is this midpoint of AD? This is also given to us. When M is the midpoint of AB, P is the midpoint of AD in triangle ADB, PM will be parallel to DB. PM will be parallel to DB, therefore I can say, and also PM is half of DB. These are all basing on the theorem which you have learnt earlier. That is, the lines joining the midpoints of two sides of a triangle is parallel to third side, and this is also half of the third side. So PM is parallel to DB, and also PM is half of DB. Similarly, the ON is parallel to DB, and also ON is half of DB. Because if you take this triangle, ON is parallel to DB, ON is half of DB. So what are you getting here, children? Therefore, PM is parallel to ON and PM is equal to ON. Is it not so, children? See, PM is parallel to DB, ON is parallel to DB. That means PM is parallel to ON, transitive property. And PM is half of DB, ON is half of DB. Therefore, PM will be equal to ON. Therefore, we will be saying that opposite sides are equal and parallel. Opposite sides are equal and parallel. Therefore, we are getting PMNO is a parallelogram. Therefore, PMNO is a parallelogram. This is the solution, children. They are asking what type of quadrilateral. That means you have to give the name, mention the name of the quadrilateral that is formed here. So to find out the name of the quadrilateral, we need to use certain properties. Say ABCD is a rhombus, of course, and M is the midpoint of AB, P is the midpoint of AD. So when you join DB, you are getting a triangle. So in a triangle, if you join midpoints of two sides of a triangle, then this will be parallel to the third side and also half of the third side. That is what the property that we have learnt. So what we can say, PM is parallel to DB and PM is half of DB. So similarly here also, in this triangle also, ON is parallel to DB and ON is half of DB. So on the whole, PM is parallel to ON and PM is equal to ON. Opposite sides are parallel and equal, then definitely it is a parallelogram. Please note it down, children. Now, children, fifth question. You have got a figure like this. And what did they say? P and Q are any points lying on CD and AD of parallelogram, respectively of parallelogram. Means CD of P lies on CD, Q lies on AD of parallelogram ABCD. You have to show that triangle APB area is equal to triangle BQC area. So what is given to us? You have got ABCD is a parallelogram and point P lies on CD and point Q lies on AD. This is given to us. And what is RTP? What is that we need to prove? Area of triangle APB is equal to area of triangle BQC. So let us go for the proof. ABCD is a parallelogram. This is given to us. We can say that triangle, therefore, triangle ABP and parallelogram ABCD lie on the same base AB and between the same parallels AB, this is one, and CD. Between the same parallels AB and CD. Triangle APB and ABCD parallelogram, they lie on the same base and in between the same parallels. Therefore, what you can say, area of triangle ABP is equal to half area of parallelogram ABCD. This is a theorem which you have got. You have learnt a theorem, children. Basing on the theorem, we will be saying that it is half of parallelogram ABCD. Similarly, we can say that area of triangle BQC is equal to half area of parallelogram ABCD. Why is it, children? Because ABCD is the parallelogram, now BC is the base, and the area of a triangle BCD or BCQ or BQC and ABCD lie on the same base BC and in between the same parallels AD and BC. Same reason, but the letters are changed, that's all. So that is why I wrote it similarly. Therefore, area of triangle BQC is nothing but half of parallelogram ABCD. So we have got RHS are equal, therefore LHS will be equal. Therefore, we will say that area of triangle ABP is equal to area of triangle BQC. This is the proof of this theorem, children. It's not a theorem, of course, a problem, but I hope I am clear. Once again, let me explain. ABCD is a parallelogram. P is a point on CD. Q is a point on AD. They have joined AP and BP, QC and QB. Now we have got two triangles. One is a triangle APB and another one is triangle BQC. They are asking to prove that the area of these two triangles are equal. So let us see one by one. Triangle APB and parallelogram ABCD are lying on the same base AB and in between the same parallels AB and CD. Therefore, area of triangle ABP is APB, anyway you can say, is half of parallelogram ABCD basing on the theorem. Similarly, area of triangle BQC will also be equal to half of area of parallelogram ABCD. So when RHS are same, LHS are same. This is the proof for children. Please note it down. With this, I am going to conclude my part today. In the next class, I will be doing the next part.